For years, Tesla has been the undisputed king of battery innovation, setting the standard with unmatched efficiency and capacity. But a new challenger has stormed onto the scene, one bold enough to push Tesla's much-hyped Cybercell into the history books. This breakthrough battery isn't just about efficiency, it delivers more power, packs greater capacity, and completely redefines what's possible for everyday use. So what kind of technology is shaking up the EV world and leaving Tesla scrambling? Let's dive in. Enter QuantumScape, the Silicon Valley disruptor taking direct aim at Tesla's throne. Founded in 2010 by Jagdeep Singh, Tim Holm, and Fritz Prinz, the company began as a small startup with a big dream. Everything changed in 2012 when Volkswagen, one of the world's automotive giants, stepped in with major funding. Soon after, even Bill Gates bet on their vision, putting his own money into the project. QuantumScape exploded into headlines in 2020 when it announced work on a battery so advanced it could leave traditional lithium-ion cells in the dust. The hype went global overnight, and investors couldn't throw money at them fast enough. But here's the real question: what exactly makes this battery so revolutionary? The answer lies in QuantumScape's next-generation solid-state batteries. Picture them as the next giant leap in EV power. For decades, solid-state has been hailed as the holy grail of battery technology, and now it's finally within reach. On the surface, they may look similar to today's lithium-ion cells, but there's a game-changing twist. Instead of liquid or gel electrolytes, these batteries use solid materials, polymers, or ceramics that unlock a new level of performance. While this might seem like a small tweak, it's a game-changer, delivering massive improvements in performance and utility. First, due to their much higher energy density, solid-state batteries have a much bigger capacity. This means they allow for a far greater range while also being lighter and more compact. That makes cars more drivable due to lower curb weight and more efficient since they're not overburdened by excess mass. Essentially, this means we'll finally be getting range-efficient vehicles that aren't unnecessarily heavy, which could also lead to considerably lower price tags for EVs in the future. What's even more interesting is that despite being lighter, solid-state batteries allow for an even higher power output than regular lithium-ion batteries. That means we'll be able to use more power and create even faster electric vehicles. On top of that, solid-state batteries have a higher voltage tolerance, which means charging times will be much faster than with regular lithium-ion batteries, solving one of the main drawbacks of EVs compared to internal combustion engine cars. But the biggest reason they're so much better than lithium-ion batteries is stability. The major concern with regular batteries is how easily combustible they are. Lithium-ion cells combine a flammable electrolyte with a significant amount of stored energy. Once the cell starts producing more heat than it can effectively disperse, it becomes highly susceptible to spontaneous combustion. This process of producing excessive heat is called thermal runaway, and it can be caused by short-circuiting, mechanical damage, or even overcharging and over-discharging. On the flip side, solid-state batteries are far more stable because they can't eject flammable or toxic gases, since they're completely solid and lack any easily flammable liquid that can vaporize. The risk is dramatically lower. What's fascinating is that solid-state batteries have existed as a concept for almost 2 centuries. Michael Faraday was the first to discover solid electrolytes back in the early 1830s, laying the foundation for all future solid-state ionic research. However, solid-state batteries were long known for their short lifespan due to the rapid depletion of their electrolytes. Even with this flaw, they remained viable as an idea for the future. QuantumScape seems to have Tesla in a tight spot with their pioneering strides in solid-state battery technology. It's only a matter of time before other manufacturers jump on the bandwagon, potentially forcing Tesla's Cybercell into early retirement. Tesla is a giant in the industry, a well-oiled machine with immense production capabilities that go far beyond research and development. Unlike QuantumScape, which is still classified as a startup focusing solely on battery research and development, Tesla has already proven itself with groundbreaking products that reshape the electric vehicle landscape. Tesla also has the resources and strategy to outmaneuver competition. Scaling up production while keeping costs down and performance reliable is a huge challenge. Many companies have failed to make that leap even with innovative technology. But if QuantumScape can overcome these obstacles and deliver a viable solid-state battery, the implications would be profound. Their technology could reshape the electric vehicle industry, making lithium-ion batteries obsolete and forcing manufacturers to rethink vehicle design from the ground up. A successful shift to solid-state would mean longer driving ranges, faster charging, improved safety, and lower costs, all factors that could drive electric vehicle adoption at a pace never seen before. This wouldn't just benefit car makers, it would also win over consumers who have hesitated to go electric due to concerns about battery life, charging infrastructure, and affordability. That said, QuantumScape's potential success doesn't mean Tesla will fail. Tesla has built an empire on continuous innovation, efficient production, and a strong market presence. They've made huge strides in lithium-ion tech, optimizing density, lifespan, and efficiency. With massive gigafactories, a loyal customer base, and diversified products spanning solar, AI, and energy storage, Tesla has undeniable advantages. If QuantumScape's batteries prove viable, Tesla has the expertise and resources to respond either by developing its own solid-state tech or acquiring a company that specializes in it. Tesla has a history of pivoting quickly when needed. For example, it has refined lithium-ion packs, introduced structural battery packs, and explored alternatives like lithium iron phosphate to reduce reliance on costly cobalt. Tesla's Cybercell may still play a role too. While QuantumScape's solid-state batteries are exciting, they won't necessarily surpass Tesla's advancements in cost-effectiveness, scalability, and integration. The success of any new battery depends not just on theory, but on whether it can be mass-produced competitively, and that's where Tesla shines. Tesla's greatest advantage in this evolving landscape may not be its current battery chemistry, but its deeply integrated and vertically scaled manufacturing prowess. The company's experience in designing the entire vehicle around the battery pack, exemplified by its structural battery architecture, gives it a significant head start in integrating any new battery technology, whether its own or an acquired one. Tesla's ability to control the entire production chain, from raw materials to final assembly, allows for rapid iteration and cost optimization that a specialized battery supplier may struggle to match. Furthermore, the impact of advanced battery technology extends far beyond the passenger vehicle market. The same solid-state batteries that promise longer range for EVs could also, revolutionize grid storage, aviation, and consumer electronics. A safer, higher-density battery would allow for larger and more efficient home and utility-scale energy storage systems, smoothing out the intermittency of renewable energy sources like solar and wind. This broader application creates additional markets and revenue streams for whoever successfully commercializes the technology, further intensifying the global race. Ultimately, the question is not if solid-state batteries will arrive, but when and from whom. The technological foundation is sound, and the immense potential rewards have ensured that investment and research will continue unabated. QuantumScape currently holds the spotlight, but they're running a marathon against some of the world's most powerful and determined corporations. The coming years will be critical. They'll separate genuine technological breakthroughs from overhyped promises, data from real-world testing, partnerships with major automakers for production vehicles, and transparent progress reports will be the true metrics of success. For consumers and the planet, the outcome holds tremendous promise. We're on the cusp of a new era in energy storage, one that promises to make electric vehicles more accessible, practical, and desirable than ever before, fundamentally transforming our relationship with transportation and energy. In the end, the real winners will be consumers. EV buyers will soon have access to cars with longer ranges, shorter charging times, and more affordable prices. Whether it's Tesla, QuantumScape, or another company that leads, the outcome will be the same. A future where EVs are the norm, not the exception. The transition to solid-state batteries, if successful, could be the final push that makes EVs the dominant form of transportation, accelerating the shift away from fossil fuels and paving the way for a cleaner, more sustainable future. As we look ahead to 2025 and beyond, all eyes are on QuantumScape and whether they can turn their ambitious vision into reality. If they succeed, they could redefine the EV industry and set a new standard for battery technology. If they fail, it'll be yet another reminder of just how hard it is to bring revolutionary breakthroughs from the lab to the real world. One thing is certain. Battery technology is evolving at an unprecedented rate, and the future of electric vehicles has never been more exciting.